Welcome to Summary Statistics, Correlations and Random Data. After completing this lesson, we should be able to compute column summary statistics, compute pairwise correlations between series and columns, and generate random data from different distributions. In the previous lesson, I've shown you that an RDD of vectors backs a row matrix. Now it is time to compute some basic summary statistics over its columns. They are available through colstats function in the statistics object. It returns an instance of multivariate statistical summary, which contains column-wise results for min, max, mean, variance, the number of non-zeros in the column, and both the L1 and L2 norms. That is, the total number of rows within each column is given by count. In this example, we're creating an RDD of vectors to store our observations. This RDD has 3 elements, each one a vector with 2 elements. This is a simple example of summary statistics. Here I apply statistics.colstats over the observations RDD and I get my desired summary of statistics. The statistics are computed on the columns. So we can see from result 0 to result 4 the column-wise results for the mean, variance, number of non-zero elements and norms L1 and L2. Now let's move to pairwise correlations among series. They are available through the correlation function named cor in the statistics object. The correlation methods supported are Pearson, the default one, and Spearman used for rank variables. The cor function also supports 2 types of inputs. You can either provide 2 RDD of doubles, representing 2 series of values, in which case the result is going to be a single double value for the correlation between both series, or you can provide an RDD of vectors, representing rows of a matrix with the series being its columns, in which case the result is a correlation matrix. This is a simple example for the Pearson correlation between 2 series. First, I create an RDD of doubles with just 3 elements on it. Call it series X. Next, I create another series with the same size and call it series Y. Then I compute the correlation between the 2 series by passing them as arguments to the cor function. The result for this simple example is minus 0.56. Now we look at an example that returns a correlation matrix. I start by creating an RDD of vectors with 3 elements, each one a dense vector of size 3. It gives me a 3 by 3 matrix. Remember, each series is a column in the matrix, so I have for the first series 2, 1 and 4. Now I compute the matrix correlation among the 3 series by passing the RDD of vectors as an argument to the cor function. The result is another 3 by 3 matrix. The third example illustrates the difference between Pearson and Spearman correlation methods. First, I create an RDD of vectors corresponding to a 3 by 3 matrix and name it ranks. If I compute the Pearson correlation matrix, I get a perfect correlation between the first and second series, but not with the third one. But if I compute the Spearman correlation matrix, I get a perfect correlation among all series, since in all 3 series the smallest value comes first and the largest one comes last. Moving across to random data generation, Apache Spark provides random RDDs which can generate either random double RDDs or random vector RDDs. Currently, 6 different statistical distributions are supported: the uniform, normal, log normal, Poisson, exponential, and gamma. This capability is useful for randomized algorithms, prototyping, and performance testing. Now we look at a simple example of generating some random data. First, I create an RDD with 1 million doubles spread across 10 partitions. I've chosen to use the Poisson distribution with mean 1. I've just computed the mean and variance to verify that it's behaving the way that we would expect it to. Now we generate a multivariate normal. First, I create a random vector RDD with 10,000 vectors of 3 elements each, divided into 10 partitions. And once again, I compute the mean and variance just to illustrate that it's behaving as we expect when sampling from a multivariate normal distribution. All vector RDDs are dimensionality of 2 or greater, and available distributions are exponential, gamma, log normal, normal, Poisson, and uniform. Having completed this lesson, we should now be able to compute column summary statistics, compute pairwise correlations between series and columns, and generate random data from different distributions.